guys, it's IDW, and today we're going to be discussing how exactly we're going to implement floating point numbers and doubles, which we've discussed previously, actually into actual CPUs. So yeah, that's the plan for today. So first of all, let's discuss floating point numbers. So as you know, a floating point number is one way of representing a number that with two numbers, only in it you round one of the digits off. And a double is where you actually have two pieces of data. One is less significant than the other, and they just attach to each other, basically. So yeah, that's exactly how you do them. And so now let's discuss how you implement them into CPUs, which, once again, is a very, very, very simple concept, unlike the actual concepts of them. So for doubles, it's pretty simple how you actually make it into a CPU. So first of all, what you're going to do is you're just going to save it in as like two pieces of data. So now let's just do like 5 and 9 in binary. And then we just split them down the middle. Now the thing that's nice about a double is that it's actually a lot easier than it is to add a floating point number. We've discussed multiplying floating point numbers, but adding two of them together is completely painful, and we're going to be discussing that a bit later. But anyways, if we were to add two floating point numbers to each other, as you can imagine, all that you would have to do is just, first of all, add the two least significant ones together, and if there is a carryout, then you increment the addition sequence between these two things. And if there's not, then you just add them together. Anyways, so, sorry about that, I sort of started randomly. Anyways, on to adding floating point numbers together. Anyways, 3, 2, 1. Anyways, on to adding floating point numbers together. This is really tricky compared to adding doubles together or multiplying two floating point numbers. What you have to do to multiply two floating point numbers by each other is you have to actually basically round them based off of the whatever it's called that is like the base thingy. The thing that is the exponent, and I'm being stupid and forgetting the name of it again. Yay! Anyway, so you take that, and you find the difference between the two of them. Right. And then you can use that to shift over both of the inputs that you need, the number of places that you need to shift them, so that they're on the right place. And then you basically just add or subtract them, and then you just round it to the more significant of the two. And you can technically shift it over again if you get a carryout, but yeah, that's not really our concern. And the odds that that's going to happen are fairly small. Yeah. Now that's just about everything that we need to cover here, except multiplying doubles. How silly of me. Okay, let's see. How does one multiply a double again? Oh, yes. So if one was to multiply a double, all that you would need to do is you just multiply this digit, and then you multiply this digit, and then you add the overlaps, and it's really as simple as that. And yeah, actually you technically do need to... Okay, I'm being silly here. What you actually have to do is, let's just say there's an imaginary second input for this right above here, right? What one would have to do is multiply this guy by this guy, one would have to multiply this guy by this guy, one would have to multiply this guy by this guy, and that guy by that guy. So you have to cross it as well as multiply the one across from it. So basically you just multiply everything by every other one of the inputs of the opposite input. So yeah, that's basically how you use it. You'll use one register to represent both parts of the floating point number and or double. And then the next thing is, in order to do this, you generally need bit shifting. So yeah, that's basically all that we need to cover in this entire series. I know it's insane. I've had a great time doing this. I hope you guys have enjoyed it, and I hope you have all learned as always. And as always, again, I'll see you guys next time.